Hi, welcome to the channel NCERT Maths Tutor. In this video, I am explaining negative angle identities. This concept is related to trigonometric functions. Consider a Cartesian plane. Let us divide the Cartesian plane into two coordinate axes, x-axis and y-axis. So here we have x, x dash, y, y dash. Now again you consider a circle on this coordinate axis. And let us say that this is the O, this O is the origin of the circle, and here we have a fixed line OR. This fixed line is moving on the circle and at some point it produces an angle theta. Let us say that the point is M. So now on this point the fixed line OR produces an angle theta, and this is nothing but the radius of the circle, which is R. So now here we can have the angle theta, and now we can draw a perpendicular line over here. So now we have a right angle triangle. Now for this right angle triangle, we can apply the trigonometric ratio values. So here if you have an angle theta, the opposite side of the angle theta is the perpendicular. So this is the perpendicular, this is the base, and this is the hypotenuse. And here see, the hypotenuse is nothing but R, which is nothing but the radius of the circle. And here this one, this perpendicular is nothing but y here, as this perpendicular is parallel to the y-axis. So I am taking here this one as y. Then in the same way here on the x-axis we have this particular line, and this is nothing but here x I am taking, which is the base value. Now apply the trigonometric ratio values. See, if I want to find out here sine theta, then sine theta is perpendicular upon hypotenuse. So perpendicular is this one and hypotenuse is this one, which is nothing but y upon r. Next, cosec theta is hypotenuse upon perpendicular, which is r by y. Cos theta is base upon hypotenuse, so x by r. Sec theta is hypotenuse upon base, which is r by x. Tan theta is perpendicular upon base, which is y upon x. Cot theta is base upon perpendicular, which is x upon y. So now here we got the value of all the trigonometric ratio theta value. Now let us find out the same angle with negative identities. So here I am considering the same circle. See, I am making slight changes here. Now we are referring the minus theta. Minus theta means you need to consider the opposite direction. See, when the angle theta is produced in this direction, that is anti-clockwise direction, then it is considered as a plus theta. And if the movement is in the opposite direction, if it is in the clockwise direction, then it is minus theta. So now let us say that this particular line OR is now moving on this opposite direction. It is moving on in the clockwise direction. And let us say that at some point P, it produces an angle theta. And now this angle is minus theta, as here this fixed line is revolving in the opposite direction or in the clockwise direction. So now this is the minus theta angle. And as here we have the minus theta angle, now I can draw the perpendicular line also. And now again I got a right angle triangle. ONP is a right angle triangle. On this right angle triangle, you can apply now the trigonometric ratio values. As you know here, this is the side opposite to the minus theta angle is known as a perpendicular. This is a base and this is a hypotenuse. And here this line is nothing but the radius of the circle. So I can take this one as r. Then this one is nothing but, this is the x-axis here we have. So this is nothing but in the place of base, I can write this one as x, small letter x. And this one, this is parallel to the y-axis, so which is nothing but small y value I can say. So here I am taking it as a minus y. As here we are referring the negative side of the y-axis. This is the positive y-axis and this is the negative y-axis. So here this one I am taking as minus y. So now if you write the trigonometric ratio, see sine minus theta. Sine minus theta is nothing but perpendicular upon hypotenuse. See, perpendicular is here minus y upon r. Hypotenuse is r. Then this one minus y by r. Here y upon r is nothing but sine theta only. See, here we have got that. Y upon r is sine theta. So in the place of y upon r, if I write the sine theta, so I get the answer minus sine theta. So we can say sine minus theta is equal to minus sine theta. Next, cosec minus theta. Cosec minus theta is hypotenuse upon perpendicular. Hypotenuse upon perpendicular, that means r upon minus y. R upon minus y. Here we have, so r upon y is cosec theta. That we have found. So r upon y is cosec theta. So r upon y cosec theta. Here we have a minus sign. So we can say that cosec minus theta is equal to minus cosec theta. Next, cos minus theta. Cos minus theta is base upon hypotenuse. Base is x upon r. X upon r. And this x upon r is nothing but here it is cos theta. So I can say that this is equal to cos theta. So cos minus theta is equal to cos theta. See, here there is no negative sign. Then sec minus theta. Sec minus theta is equal to hypotenuse upon base. Hypotenuse is r and base is x. So r upon x. And this r upon x is nothing but sec theta. So sec minus theta is equal to sec theta. Then tan minus theta. Tan minus theta is equal to perpendicular upon base. So perpendicular upon base, that is minus y upon x. So y upon x is nothing but tan theta here. So that means minus, this becomes minus tan theta. So tan minus theta is equal to minus tan theta. Then cot minus theta. Cot minus theta is equal to base upon perpendicular. So x upon minus y. So that is equal to x upon y is cot theta. So minus cot theta. So cot minus theta is equal to minus cot theta. See, here we can have all the 6 negative angle identities. Sin minus theta is equal to minus sin theta. Cosec minus theta is equal to minus cosec theta. Cos minus theta is equal to cos theta. Sec minus theta is equal to sec theta. Tan minus theta is equal to minus tan theta. And cot minus theta is equal to minus cot theta. And here you can observe that cos minus theta and sec minus theta, they are not negative values. They are giving the positive values. Here the negative sign is eliminated. Here we don't have a negative sign. Whereas in other trigonometric ratios, we have a negative sign. The reason is that here this minus theta it is in the 4th quadrant. And you know, in the 4th quadrant, all sin, tan, cos and sec are positive. That is the reason that here you are getting cos theta positive as well as sec theta positive. So this is about negative angle identities. If you like this video, please click the like button and also subscribe to the channel NCERT Maths Tutor to get more regular updates. Thanks for watching.